Right. Get ready. We're diving deep into machine learning today. Not the simple stuff, though.
Yeah.
We're going way past the basics.
Think of it as, well, dissecting an article we found from the OpenAPI Hub community.
Yeah, like really getting into the nuts and bolts.
It's called The Journey of Machine Learning, From Concept to Reality.
And get this, it was published just last week.
So it's really fresh, you know?
Super fresh. So everyone knows about things like Amazon recommendations and how they seem to know what you want before you do.
Right, or how about fraud detections, like magic, right?
Total magic. But we're going to look at how that magic actually works.
We're going to uncover what makes all that stuff tick.
Exactly. And then just to spice things up, we're going to talk about the challenges.
Because even the coolest tech can have, well, you know, its downsides.
Absolutely. And I promise by the end of this, you'll be asking some pretty big questions about the future of all this.
Oh, yeah, some real mind benders.
Okay, so let's start at the beginning. When we talk about the history of machine learning, where's the real starting point?
Well, I think you got to go all the way back to 1958 and the perceptron.
The perceptron. That sounds, I don't know, almost mythical.
It kind of is. It was the first artificial neural network that could actually learn from data.
So like the first attempt to make a computer think like a brain?
Kind of, but a really, really simple brain. It could only work with data that was linearly separable. You know, it couldn't deal with the really complex stuff that we use in machine learning today.
So it was like a baby step, but an important one.
Yeah, exactly. It was about laying the foundation, figuring out what the challenges were, and the big one was handling those complex patterns in data.
And that's where the M&S database comes in, right? 1998, was that a big year?
Huge. It was this standardized data set of 70,000 handwritten digits. It became the benchmark for image recognition.
So before that, everyone was just using whatever data they had.
Yeah, it was a mess. Hard to compare results. M&S made things, well, it gave everyone the same ruler to measure with.
So it was like setting a standard for everyone working on image recognition.
And then came Linet 5, this early convolutional neural network, and it got over 99% accuracy on MNIST.
Wow, 99%. That's insane.
Yeah, it was a real proof of concept, showed everyone what deep learning could do, how it could basically see like a human.
That's amazing, especially back then in 98. So what came next?
Things really took off, but not overnight. We saw these huge image data sets emerge in the 2010s, like ImageNet and COCO.
So compared to MNIST, these were like...
Well, MNIST was like learning your ABCs. ImageNet and COCO were like, I don't know, writing your PhD dissertation. Millions of images, tons of different objects and scenes, way more challenging.
And of course, you can't have a challenge without someone trying to beat it.
Exactly. And we got algorithms like AlexNet, Faster RCNN, and YOLO. All of them got insanely good at object detection and image classification.
So every time someone threw more data at the problem, someone else came up with a better algorithm.
And don't forget, all of this wasn't just for fun. This stuff was driving real-world applications. Self-driving cars, medical imaging, all that started here.
Right, right. Okay, so image recognition was booming, but machine learning isn't just about looking at pictures, right?
Nope, there's the whole world of language, too.
Language is way more complex, right? All those nuances and double meanings and stuff.
You're telling me. And in 2018, we got GLUE, this benchmark all about natural language understanding.
So this was about making computers not just read words, but actually understand what they mean, like in context.
Yeah, like understanding sarcasm or figuring out if someone's happy or sad based on what they write, that kind of thing.
That sounds really hard to teach a computer.
It is. But then BERT came along and just blew everyone away. It aced all these different GLUE tasks.
What made BERT so special?
Well, BERT was all about context. It could look at a word and understand its meaning based on the words before and after it. Kind of like how we read, you know?
So it was a big step forward in making computers think more like us.
Definitely. But 2018 wasn't just about algorithms. We also got MLPerf.
MLPerf. What's that?
It was this new benchmark, but it wasn't just about how good the algorithm was. It also looked at the hardware and software running it.
So it was about making sure that these brilliant algorithms could actually run efficiently in the real world.
Exactly. You could have the smartest algorithm ever, but if it takes a week in a supercomputer to run, it's not that useful, right?
Makes sense. So we've got this amazing history, breakthroughs in image recognition and language processing. But now I want to get into the nitty-gritty. How does this stuff actually work?
All right, let's crack it open and see what's inside.
Perfect. Give me the first key ingredient.
Data. It all starts with data. Algorithms learn by finding patterns in data.
So no data, no learning.
Pretty much. But it's not just about how much data you have. The quality of the data is super important too. Bad data means a bad model.
Like putting bad gas in your car.
Yeah, exactly. It's not going to run very well.
Okay, so data is the foundation. What else do we need?
Features. Think of these as the interesting bits of the data. Let's say you're trying to predict house prices. Square footage, the number of bedrooms, stuff like that. Those are your features.
So it's like highlighting the important stuff in the data for the algorithm to focus on.
Yeah, kind of. And sometimes we create new features by combining existing ones. This can get really tricky, but it's often the key to getting better results.
So it's like detective work, finding clues in the data.
Exactly.
All right, what's the next piece of the puzzle?
Algorithms, the heart of it all. These are the mathematical models that actually process the data and learn from it. They're like the engine of the whole thing.
So we've got data as fuel, features as a map, and the algorithm as the engine. But how does the engine actually learn?
That's where training comes in. We feed the data to the algorithm, and it starts figuring things out, adjusting itself to make fewer mistakes. It's like teaching a dog a trick, rewards and corrections.
So it's a process of trial and error, basically.
Yeah, exactly. And to make sure it doesn't just memorize the training data and then fail in the real world, we use something called a validation set. It's like a practice test.
So it's learning the general rules, not just memorizing the answers.
Right.
Okay, so we've trained the model, given it a practice test. How do we know if it's actually ready for the real world?
That's where testing comes in. We give it a final exam, a data set it's never seen before, and see how well it does. That tells us if it can generalize what it's learned.
So data, features, algorithms, training, and testing. The 5 pillars of machine learning.
That's it. Those are the basics.
But I'm sure everyone's thinking, okay, that's cool, but what can you actually do with this stuff?
Well, now's the fun part. Let's talk about how machine learning is changing the world right now.
Hit me with some examples.
How about those personalized recommendations you get on Amazon or Netflix? That's machine learning. Figuring out what you might like based on what you've done before.
It's kind of creepy how well they know me sometimes.
I know, right? But it's just math, really. And it's not all about entertainment either. PayPal uses machine learning to catch fraudsters before they can steal your money.
So it's like a digital bodyguard for our bank accounts.
Exactly. And then there's IBM Watson. It can analyze tons of text like customer reviews or social media posts and figure out what people are thinking and feeling.
So businesses can use that to understand their customers better.
Yeah. Or to see how people are reacting to a new product or a marketing campaign.
Pretty powerful stuff.
Yeah.
What else?
Well, everyone knows about facial recognition. Facebook uses it to tag people in photos.
Which has its own set of issues, privacy and all that.
Definitely. But the technology itself can be used for good, too, like in security or law enforcement. Even in healthcare, it can help diagnose diseases.
So it's all about how we use it, I guess. What other areas is machine learning impacting?
Healthcare is a big one. Google Health has developed these models that can actually diagnose diseases from medical images, sometimes even better than human doctors.
Wow, so machines are actually saving lives now.
And that's just the beginning. Imagine personalized medicine tailored to your specific genes. Or AI assistants helping doctors make decisions and freeing up their time to spend with patients.
Sounds pretty amazing. What else?
Transportation's being transformed too. Tesla's autopilot, all that self-driving stuff relies heavily on machine learning.
So self-driving cars are a reality now, not just a sci-fi fantasy.
Yep, and they're only getting better. And don't forget about all the behind-the-scenes stuff like supply chain optimization. Walmart uses machine learning to predict what people are going to buy and make sure their stores have the right stuff in stock.
So it's not all flashy robots and self-driving cars. It's making everyday things more efficient too.
Absolutely. And that's just scratching the surface. Machine learning is touching pretty much every part of our lives already, and it's only going to get more pervasive in the future.
It's kind of mind-blowing when you think about it.
It really is. And the crazy thing is we're still just at the beginning of this whole machine learning revolution. Who knows what the next few years will bring?
That's a great point. But before we jump into the future, let's take a closer look at some of the frontiers of machine learning, the cutting-edge stuff that's really pushing the boundaries.
Sounds good. Where do you want to start? It really is mind-blowing, isn't it? All these advancements, I mean, it's hard to keep up sometimes.
Absolutely. And it feels like we're just scratching the surface. So many possibilities, so many different directions this could go.
Exactly. And that's what I find so exciting. There are these frontiers in machine learning that just, well, they make you think, what's next? You know?
Oh, totally. So what are some of these frontiers that have you particularly fired up? Where do you see the biggest potential for breakthroughs?
One area that I think is absolutely crucial is explainable AI, XAI for short. Remember we talked about that black box problem earlier?
Yeah, the whole thing about how sometimes even the people who build these models don't fully understand how they're making decisions.
Right. And that's a problem, especially if we're going to trust these systems with important stuff like healthcare or finance. So XAI is all about making these models more transparent.
So it's like opening up the black box and seeing the gears turning, understanding the why behind the what.
Exactly. It's about building trust. If we can see how the sausage is made, so to speak, we're more likely to feel comfortable eating it.
Makes sense. What else is on your radar?
Well, there's federated learning. This one's really interesting. Imagine training a machine learning model on data that's spread across a bunch of different devices.
Wait, so instead of gathering all the data in one place, you're training the model on data that stays on people's phones or computers.
Exactly. It's all about privacy. We can still build powerful models without having to collect everyone's personal data in one giant vulnerable database.
That's pretty amazing. Sounds like it could be a game changer for all sorts of applications.
Oh, absolutely. And then there's reinforcement learning. This is where algorithms learn through trial and error, kind of like how we learn.
So instead of being explicitly programmed, they're figuring things out on their own through experimentation.
Exactly. It's already being used in robotics and game playing, but I think it has huge potential in other areas too, like personalized medicine or controlling complex systems.
It sounds like we're moving towards a future where machines are less like tools and more like partners, learning and adapting alongside us.
I think that's a great way to put it. It's not just about making machines smarter. It's about making them more adaptable, more robust, more able to handle the messy complexities of the real world.
It's fascinating how all these different frontiers, explainable AI, federated learning, reinforcement learning, they're all addressing the limitations of traditional machine learning in their own way.
Absolutely. They're pushing the boundaries of what's possible, but they also bring up a whole new set of challenges.
Challenges like what?
Well, as machine learning gets more powerful and more integrated into our lives, we need to be even more careful about things like bias, fairness, accountability.
So it's not just about the technology itself. It's about how we use it.
Exactly. We need to make sure these systems are being used responsibly and ethically, with safeguards in place to prevent unintended consequences.
It's like we're at a crossroads, and we have to choose the right path forward, a path that leads to a better future for everyone, not just a select few.
I completely agree. It's a huge responsibility, but it's also an incredible opportunity.
So what can we do? What are some concrete steps we can take to make sure the machine learning is used for good?
Well, one crucial thing is diversity and inclusion. We need more people from different backgrounds, different perspectives involved in building these systems.
Because if the people building the technology are all from the same group with the same biases, those biases are going to get baked into the systems themselves.
Exactly. And it's not just about diversity within the tech industry. We need to involve experts from other fields too. Ethicists, philosophers, social scientists, lawyers, all these different perspectives can help us make sure that machine learning aligns with our values as a society.
It's like a multidisciplinary approach, bringing everyone to the table to figure out how to navigate this new landscape responsibly.
Exactly. It's about having those tough conversations early on, anticipating potential pitfalls, and proactively shaping the ethical landscape of AI.
I love that. Proactively shaping the ethical landscape. That's what we need to be doing. So with all that said, are there any real-world applications of machine learning that you find particularly inspiring?
Oh, there are so many, but healthcare is definitely high on the list. Seeing how machine learning is being used to diagnose diseases earlier and more accurately, to personalize treatment plans, even to accelerate drug discovery, it's really amazing.
It's like machine learning is becoming a powerful tool in the fight against disease.
Absolutely. And it's not just about robots performing surgery or anything like that. It's impacting healthcare at every level, from diagnostics to treatment to prevention.
That's fantastic. What other areas are seeing positive change thanks to machine learning?
Well, sustainability and environmental conservation are huge areas of potential. Machine learning is being used to optimize energy consumption, predict natural disasters, track deforestation, protect endangered species, you name it.
It's incredible to think that we can use this technology to help us understand and address some of the biggest challenges facing our planet.
It's not just about analyzing data either. Machine learning is being used to develop new technologies and solutions that can help us mitigate climate change, conserve resources, and build a more sustainable future.
It's inspiring to see how this technology is being used to make a real difference in the world.
Absolutely. But there's one more area I'd love to touch on before we wrap up. the intersection of machine learning and creativity.
Oh, yes. That's a fascinating topic. It seems like the lines between art and technology are getting blurrier all the time.
It's remarkable what's happening. We're seeing algorithms that can compose music, generate art, write poetry, even create entire films. It's pushing the boundaries of what we thought was possible in the realm of human creativity.
It's almost like machines are tapping into a wellspring of creativity that we're only just beginning to understand.
It really is mind-boggling. And what's even more interesting is that machine learning isn't replacing human creativity, it's augmenting it. It's giving artists new tools and possibilities to explore.
So it's like a collaboration, a partnership between human and machine.
Exactly. It's a beautiful example of how technology can enhance and expand our creative potential, open up new avenues of expression.
It's a really exciting time to be an artist, that's for sure. But I have to ask, do you think these algorithms will ever be able to truly understand and replicate the nuances of human emotion and artistic expression? Will they ever be able to capture the soul of art?
That's a deep question, and I think it's one that philosophers and artists will be debating for years to come. It's important to remember that machine learning is a reflection of the data it's trained on, and that data ultimately comes from human experience and creativity.
So even if algorithms can create art that's technically impressive, it's still rooted in human expression in some way.
That's my take on it. Machine learning can mimic, it can extrapolate, it can create variations on a theme, but I believe that spark of original artistic inspiration, that ability to convey deep emotion and connect with an audience on a human level, that still lies within the realm of human experience.
That's a really thought-provoking perspective. It seems like the relationship between machine learning and creativity is going to continue to evolve in fascinating and unpredictable ways.
Absolutely. It's a journey of discovery, and I'm really excited to see what the future holds.
Me too. But before we get too carried away with future predictions, let's take a step back and recap what we've explored today. We've covered a lot of ground, from the history of machine learning to its inner workings, to its impact on everything from healthcare and sustainability to creative expression. We even touched on the ethical considerations and the importance of responsible development.
It's been quite a journey, hasn't it? Exploring not just the technical marvels of machine learning, but also its profound implications for society and the very nature of human creativity.
Well said. And as we wrap up this part of our deep dive, I can't help but feel a sense of awe and wonder at the possibilities that lie ahead. But I also recognize the weight of responsibility that comes with such power, the need to ensure that machine learning is used ethically and for the benefit of all humankind.
That's a sentiment I completely share. The future of machine learning isn't predetermined. It's a story that's still being written, and we all have a role to play in shaping its narrative. It really is a story in progress, with so many twists and turns still to come.
Absolutely. And we've talked about all these advancements and possibilities, but now I think it's time to get, well, a little more personal.
Oh, you mean like where do we fit into all of this?
Exactly. Because it's easy to get caught up in the tech itself, but at the end of the day, machine learning is a tool. And like any tool, it can be used for good or for bad.
Right. And the way it's used, the direction it goes, that's ultimately up to us, isn't it?
It is. So I guess the question is, as machine learning keeps evolving, what role do you see yourself playing in all of this? Are you just going to sit back and watch it happen?
Or are you going to roll up your sleeves and get involved?
Yeah, because there are so many ways to be a part of this. You could be a developer, a researcher, an advocate, an artist, even a critic, pushing for responsible and ethical use.
It's not just about career choices either, is it?
No, it's bigger than that. It's about our fundamental relationship with technology.
Are we going to let it shape us, or are we going to shape it?
And that's a question each of us has to answer for ourselves.
Yeah, no one can answer that for you.
So as we wrap up this deep dive into the world of machine learning, I hope everyone listening is feeling, I don't know, a little bit inspired, a lot of challenged.
I hope so too, because machine learning is here to stay.
It is. And it's going to keep changing the world in ways we can't even imagine yet. But how it changes the world, that's still up in the air.
And we all have a part to play in that.
We do. So keep exploring, keep questioning, and keep imagining the possibilities. Because the future of machine learning is, well, it's what we make it.
Couldn't have said it better myself.
And that's a wrap on the deep dive. Thanks for listening, everyone.